Hello everyone, this is Adithi studying in Sri Venkateswara College of Engineering, and today I'm going to discuss about probability, mass, function and distribution. Today we are going to talk about probability mass function, example problem of probability mass, applications of probability mass, probability distribution, example problem of probability distribution and applications of probability distribution. What is probability mass function? Probability mass is defined as a function which gives the probability that a discrete random variable is exactly equal to same value. It is also known as discrete probability density function. The probability mass function is often the primary means of defining a discrete probability distribution, and such functions exist for either scalar or multivariate random variables whose domain is discrete. If for each value of x of I of a discrete random variable x, we assign a real number p of xi such that p of xi is greater than or equal to 0, summation of p of xi is equal to 1. Then the function p of x is known as probability function. If the probability that the x can take the values xi is p of I, then p of the brackets x is equal to xi is equal to pi of p of xi. The set of values xi comma p of xi is called discrete finite probability distribution of the discrete random variable x. The function p of x is called the probability density function or the probability mass function. Mean is calculated by the formula summation of xi dot p of x. Similarly, variation is calculated by the formula summation xi square p of x minus square. Let's see a problem based on probability mass function. A coin is tossed twice. A random variable x represents the number of heads turning up. Find the discrete probability distribution for x. Also determine its mean and variance. Here, first you need to write the samples, that is head tail, tail head, tail, and the sample space contains the following heads in each case, that is 2, 1, 1, 0. First find the probability of x is equal to 0, that is 1 by 4. Similarly, p of x is equal to 1, that is 1 by 2, and p of x is equal to 1 by 4. And form the table as shown below. To find the mean, multiply the xi value multiply the xi value and the p of xi value, which gives 0 plus 1 by 2 plus 1 by 4, which is equal to 1. To find variance, use the formula summation xi square dot p of x minus mu square. For this, multiply the square of xi into p of xi. So you get 0 plus 1 by 2 plus 1 minus 1 is equal to 1 by 2. The applications of probability mass function, they are statistics and data analysis. PMFs are used extensively in statistics to analyze and model discrete data. They help in understanding the likelihood of different outcomes in scenarios such as survey responses, game outcomes, or product defect rates. In manufacturing processes, PMFs can model the probability distribution of defective products or faults in production line, aiding in quality control strategies. Next, probability distribution. A probability distribution is a mathematical function that describes the likelihood of a different outcomes or events in a particular scenario. It provides a way to quantify uncertainty by assigning probabilities to various possible outcomes of a random experiment or a random variable. Discrete probability distribution. This type of distribution is associated with discrete random variables which have a countable number of possible outcomes. Examples include the binomial distribution, Poisson distribution, and geometric distribution. Continuous probability function. It applies to continuous random variables that can take any value within a specified range. Examples include the normal distribution, exponential distribution, and the normal distribution. Let's see a problem on probability distribution. Show that the following distribution represent a discrete probability distribution. Find the mean and variance. So the table is given as x and p of x. The values of x are 10, 20, 30, 40, and values of p of x are 1 by 8, 3 by 8, 3 by 8, 1 by 8. We observe that p of x is greater than 0 from the and sum of p of x is equal to 1 from the probability mass function. So mean is equal to mu, which can be calculated by using the formula summation of x into p of x, which gives 10 by 8 plus 60 by 8 plus 90 by 8 plus 40 by 8, that is equal to 25. And variance can be calculated by summation of x and square by p of x minus mu square. 100 by 8 plus 1200 by 8 plus 2700 by 8 plus 1600 by 8 minus 5000 is equal to 600 by 8, which is 75. So the mean and the variance values are 25 and 75. Applications of probability distribution. It is used in engineering and physics. In engineering, probability distributions are used to model the reliability of systems, failure rates, and lifetimes of components. In physics, distributions describe phenomena such as particle decay, energy levels, and quantum states. The second application is telecommunications and networking. Probability distributions are used to model data traffic, packet arrival times, and signal strength variations in communication networks. They aid in designing the optimizing network protocols and resource allocation. Machine learning and data science probability distributions are fundamentally machine learning for modeling data and uncertainty. They are used in various algorithms like hidden Markov models and Bayesian interface models. Thank you.